All right, class. By show of hands, who here is not afraid of parasites? Raise your hand. Hands up if you're not afraid of parasites. Hands up. Not afraid of parasites. Raise your hand if you're not afraid of parasites. I don't see any hands going up. Curious, isn't it? Everybody's afraid of parasites. Oh, parasites get such a bad rap. There was a lecture recently by a Dr. Kevin Lafferty. There he is at the Cabrillo Marine Aquarium, talking about his life's research, which has been parasites. Well, and the sorts of studies he's talking about involve understanding beneficial parasites. Now, there's a thought, isn't there? Let me give you an illustration. He gives it in this lecture. I'm going to post the lecture below so you'll be able to go back and watch it. It really is remarkable and worth paying attention to. In Japan, there is a brown brook trout that has been nearing extinction. It's been fished almost to the point where it no longer can be found in the wild. So a group of scientists began to study this brook trout, and they found something very interesting. Their results drove them to Dr. Lafferty to investigate the effects of a parasite on providing nutrition in adequate quantity, volume, to be able to reinstate the brown trout in its natural environment. And here's what they discovered. Dr. Laverty has been working on the influence that a parasite has on its host to get it to do things, to get it to act in certain ways. There is, for example, a parasite that affects the brain of little fish, little darters. And it causes those darters to act in a way that's unusual. They flick, they lay on their side, they bounce up and down. They're perfectly healthy. They're not sick, they're not damaged, they're not diseased, but they act funny. And it draws the attention of birds that are hunting for little fish, and they snag them. It singles out that one among the many, and they snag it and they eat it. Now, what's the point of that? The point is that that parasite needs to get into a bird host out of the fish in order to be able to continue its reproductive cycle. And so it causes the fish to act in such a way as to cause the bird to eat it. Back to Japan. There is a parasite, a very long, thin parasite that infects crickets. Crickets. And it causes the cricket at a certain point in time, typically in the fall, early in the fall. It causes the cricket to become extremely thirsty to the point where it jumps into a body of water, a stream, a creek, where, of course, it drowns. Crickets can't swim. If you've ever kept crickets to raise them, you know perfectly well the worst thing you can do is put a little dish of water in there because they'll all drown in it. They'll everyone jump into it and they'll everyone drown. So this worm causes the cricket to become so thirsty that it jumps into the water and drowns. By the millions, this happens. By the millions. And then what happens? Well, the parasite comes out of the cricket, actually punctures the gut and comes out of the gut and finds another little cricket parasite worm to mate with. And they lay eggs and have babies, and the cycle starts all over again. But what happens to that cricket that's jumped in the water? Well, it's eaten by brown trout, brown brook trout. They studied then the diet of the brook trout through the year. Early in the year, it's eating insects, eating some microfauna, some plant material, primarily insects that it finds on the bottom. But then in the fall, it gorges on parasites. On crickets. Gorges on crickets. 60% of its annual food is those crickets, causing the fish to egg up, to spawn, and to duplicate, to multiply itself. So what they discovered is that the Japanese scientists discovered that the cricket is key to the health of the brook trout, the brown trout. And that the cricket getting into the water, becoming available to the brown trout, is a function of a parasite causing it to happen. So, here we have two cases, and there's a third one having to do with snails. Snails that have parasites and snails that don't have parasites. The ones that have parasites are the ones that are eaten by birds, and the others are not. At least not to nearly the degree. Parasites. Parasites cause their hosts to do things. Now, here's the thing. I want to show you another video because parasites have everything to do with diversity in your aquarium. Most especially the control of parasites. Here's a good example. Here's a tank set up by Joshua. Joshua is one of our Discord denizens who has developed a food web deep substrate. Now, if you'll notice, the bottom of this aquarium is loaded, completely covered with leaves, 2 to 3 inches of leaves all over the bottom of this thing. That promotes microfauna and microflora. Now, you might say, yeah, but what about all the parasites that'll come in? I'm scared of those parasites. Well, here we go. It's precisely the issue. In a biodiverse environment, the greater the biodiversity, the more control of the species exists within that environment. There are, for example, parasites that have parasites. There are parasites that parasite on parasites. How do you get them? Well, you get them the way Joshua got them. You go out in the creek, you collect a bunch of leaves, you bring them in, and you throw them in a fish tank. And you increase your biodiversity. By increasing your biodiversity, you increase the opportunity for everything that is living in your environment to be in a more effective balance. Think about it this way. Let's say you do not have any biodiversity in your aquarium. What you're trying to do in this scenario is keep your aquarium absolutely sterile, perfectly clean, with nothing in there living except a couple of fish. You don't even want plants in it because they bring stuff in. No plants. You don't want anything on the bottom because stuff grows on the bottom. So bare tank, bare tank. Brand new, clear, pure water. Fish. A couple little fish swimming around. All right. Okay, so far. So now what do? Well, you have to feed them. You have to feed them. How do you feed them? You get this little can of food. I don't have any here. I keep throwing it away. Little can of food. Open it up. Pour some out. Sprinkle it in. They come up, they eat. Oh boy, look at them go. Look at them go. Wow, they love this. Give them a little more. A little more. Oh boy, look at that. They're going after it, aren't they? Come here, Matilda. Look at this. Look at these guys eat. Wow. Well, they're something, aren't they? Look at that. Oh, dinner's ready? All right. Well, my fish have eaten. Time for me to eat. An hour later, you come back, and there's food laying on the bottom. Well, gee, guess I gave them a little bit too much. Well, they'll eat it. They'll eat it. They're hungry. They'll eat it. Hungry fish is a happy fish. They'll get hungry and be happy. Ah, great. Come back next day. Huh. Well, water's cloudy. Wonder what's going on. Why is my water cloudy? Huh. Matilda, did you put anything in here? Make this water cloudy?
No, Henry, I didn't do anything to your damn fish. Nothing. I don't touch your fish.
Well, something happened. Guess I have to do a water change. Get out the siphon in the bucket, pull it out, put some more in. They must be hungry. Give them a little more food. Well, this goes on. This goes on for a few days, maybe for a week. And eventually the fish begin dying. What's causing my... Matilda? Did you put anything in here to kill my fish?
No, Henry, I don't mess with your fish. They're your fish. They ain't my fish. I don't want nothing to do with them.
Well, something happened to my fish. Huh. They're all dying. Look at them. Spinning around. They got crud all over them. Look at them. Whew. Dreadful. Dreadful. Guess I need to do a water change. Man, they look bad. I better get some medicine for them. Trucks off to the store. Comes back with about 5 medications. Starts dumping them in. Whew, boy, glad I caught that in time. Goes off to dinner, to bed. Next morning, everything is dead. Now, what happened? What happened? What happened, he had a sterile tank in which there was nothing to compensate for the excess food he was feeding, or for that matter, for the waste that the fish were producing. And so a monoculture developed. A monoculture being whatever animal was there first, bacteria, whatever it was, parasite, whatever, took advantage of that environment, exploded in that environment, and took down the fish. That's what happens in a sterile environment. That's what happens when you try to keep your tank clean. clean is the enemy of a healthy tank. But I'm afraid of parasites. Well, we're all afraid of parasites, aren't we? We all are. Parasites are a dreadful thing. We don't want parasites in our tank, do we? Not a bit of it. So what do we do about it? We bring in the enemies of the parasite. We bring in the parasites that eat parasites. We increase the biodiversity of the environment, and in so doing, we rid ourselves of the real nasties. Want to see some nasties? Look at these guys. Are they dreadful or what? Nasties. How do we get rid of them? We get rid of them by increasing the diversity in our environment, such that when these little guys pop up, they get dealt with very quickly. You may wind up with a problem at some point. The likelihood is you won't. Or if it affects one fish, it'll affect one fish and not all. The likelihood is there is a parasite in there. There is something in there that's going to control these little buggers. So you won't need to be overwhelmed with apprehension and fear about being dealt a terrible blow. While I'm in this mode, I want to introduce someone to you who I met some time ago and kind of just came across again today. His name is E.J. Brinegar or Brinagar or Brinagar. I'll post his link below. He's been around YouTube for a long time. Has a very small group of followers, 324 subscribers, and he's been here for, Lord, I don't know, since, let's see, 2010, 11 years. In 11 years, he's got 324 subscribers. But I'll tell you something, this man is an absolute genius at developing a very wide range of live foods. Now, live foods are really critical if you're developing a biodiverse system because they provide not only food, they also provide a foraging. They provide a means of being able to control and to balance the biosphere. They will control other insects, other animals. They'll control parasites. They'll go a long way toward helping you balance your tank. Check out Browniger's website. The link will be below. It's remarkable, and it will teach you in a very simple, direct way how to keep a wide variety of live foods. Well, that's a little bit of a touch on the whole issue of parasites. The way to deal with parasites is not to try to get rid and kill everything. The way to deal with parasites is just the opposite. It is to bring as much life, as much biodiversity into your aquarium as you possibly can. That will balance the parasite involvement. Parasites comprise nearly 50% of the life forms in aquatic environments. If you want to control them, you got to get a lot going on. A lot of parasites will parasitize on other parasites. And there are other critters that do as well. Mainly, you've got an environment then in which the parasites don't get everything. They don't get the bulk of the nourishment. It's shared, it's spread around. and it's separated, and they're separated from it. So it creates a balance, a healthy balance, a balance in which your fish can manage to live through all of the critters that are living in the tank because they've got friends there as well as enemies. Balance your aquarium. Do what Josh has done with this remarkable leafed aquarium he has. A very, very healthy tank with lots and lots going on. So there's a new way of thinking about parasites. You don't need to get overwhelmed by them. You need to overwhelm them with good stuff. All right. Enough for this for now. Bye for now. See you again shortly.